You know that feeling when you're talking to an AI and it just isn't getting it? I mean, it understands the words, sure, but what about the feeling behind them? Well, today, we're diving into the pretty wild science of AI that can actually hear our feelings. I mean, just think about it. What if your virtual assistant could actually notice the frustration in your voice and, change its approach? Or a customer service bot could recognize you're upset and immediately get you to a human? This stuff isn't science fiction anymore. It's a real and rapidly growing field of AI. So, what are we really talking about here? Well, it's called speech emotion recognition, or SER for short. And at its core, it's all about teaching machines to listen for those super subtle clues in our voices. The tone, the pitch, the intensity, to figure out if we're happy, sad, angry, or something else entirely. It's basically like building a bridge between raw human emotion and cold, hard machine logic. Okay, but how on earth do you actually teach a computer to hear an emotion, right? It's not magic, but it is a really clever process. So let's break down exactly how these systems are built, right from the ground up. The easiest way to think about it is like a 3-step recipe. Super simple. First, you've got to gather your ingredients, in this case, thousands of voices. Then you need to extract the flavor. Those are the emotional clues. And finally, you train the chef, that's the AI brain, to recognize it all. All right, step 1. As with pretty much all AI, it all starts with data. And for SER, that means massive databases of voice recordings. We're talking thousands upon thousands of audio clips where actors or volunteers have expressed really specific emotions. And every single clip is carefully labeled. This one is happy, this one is angry. You get the picture. A really popular dataset researchers use for this is called RAVDESS, which is just this huge library for the AI to learn from. Okay, so now we've got all this data. What's next? The machine has to analyze these voices, but it can't just listen the way we do. Instead, it does something called feature extraction. And the best way to think of this is like finding a unique vocal fingerprint for each emotion. The AI literally breaks down the sound wave to find all these measurable, defining characteristics. So what's actually in this vocal fingerprint? Well, it's a few key things. It looks at something called MFCCs, which, sounds complicated, but it's basically the unique shape and quality of your voice. Then there's pitch, how high or low you speak. Think about how your voice naturally goes up when you're excited. It also analyzes energy, that's just the intensity and the volume. And finally, it looks at spectral features, which is really just a fancy way of saying it analyzes the whole mix of frequencies in your voice. Okay, so once the AI has all these numerical fingerprints, this is where the learning really begins. It just sifts through thousands and thousands of examples connecting the dots. It learns that, say, a fingerprint with a high pitch and high energy usually matches up with the label happy. It's really just pattern recognition, but on an absolutely massive scale. Now, it's not like there's just one type of AI brain for this job. Researchers use a bunch of different models. You've got things like support vector machines, which are really good at drawing a clear line between two emotions, like happy versus sad. Then you have the heavy hitters, like deep neural networks, that are amazing at finding really subtle patterns in tons of data. But no matter which model they use, the goal is always the same, to accurately classify an emotion based on that vocal fingerprint. All right, so that's all the theory, that's how it's built, but let's get into the fun part. Let's move into the real world and see how this tech is actually being used and, how well it even performs. And that really is the big question, isn't it? I mean, it's one thing to build a model in a perfect lab setting, but it's a whole other thing for it to work reliably out in the messy real world. So how do we even measure if it's successful? Well, one of the main tools researchers use is something called a confusion matrix. It sounds a little complex, but the idea is actually super simple. Let's just look at this example here. On the left, you've got the actual emotion, and across the top, that's what the AI predicted. So ideally, you'd want to see 100% all the way down that diagonal line. But look here, when a voice was actually happy, the AI got it right 90% of the time. But it got confused and thought it was sad 10% of the time. A chart like this is great because it helps pinpoint exactly where the AI is doing well and where it's, getting confused and needs more training. And the results, honestly, they can be pretty impressive. In those controlled lab tests, using really clean audio from datasets like RAVDESS, these models can hit accuracy rates as high as 95%. That is incredibly powerful. And even though there's still the challenge of making it work perfectly in our noisy, unpredictable world, that level of accuracy is already opening up some serious doors.
So where is this technology actually making a difference today? Well, the applications are pretty huge. In healthcare, it could help monitor what are called vocal biomarkers for mental health conditions. In customer service, it's already being used to analyze call center recordings to figure out how satisfied customers are. Though, let's be real, it's still learning the very tricky difference between genuine frustration and, heavy sarcasm. And of course, this is the engine that's going to build those much more empathetic and responsive AI assistants that we were talking about earlier.
Look, this technology is already incredibly powerful, but believe it or not, it's really just getting started. So let's peek over the horizon a bit and see where this is all headed. Right now, the future is focused on a few really key areas. First, deeper learning. Researchers are using even more advanced neural networks to get higher and higher accuracy, especially in noisy real-world places. A massive goal is multilingual understanding, making SER work no matter what language you speak or what your cultural background is. And then there's the holy grail, seamless real-time analysis. The dream is an AI that can respond to your emotional state instantly, right in the middle of a conversation.
And all of this, it kind of leads to one final, much bigger question. As we build these AIs that can literally hear our feelings, we're not just solving a technical problem, are we? We're also deciding how we want our technology to interact with us on a really deep, fundamentally human level. So as AI gets better and better at understanding us, what should we teach it about being human?